This is the P3 replay for lesson 10. It's from the 12 p.m. discussion, and the problem here deals with drawing the structure of a polycyclic aromatic compound based on its molecular orbital energy diagram, which you see here on the left that the student is checking over, and in particular the number of pi electrons present in the compound. So you'll see the student take a couple of stabs at the problem and eventually reason his way through it. I think throughout the process kind of maintaining his composure even when time gets short. So we've seen this before, and it may happen to you quite a bit that the first answer you submit will be incorrect. So be prepared to maintain your composure in the face of that in an exam situation, and you'll set yourself up for success, right? Because getting a problem correct on the second attempt is just 1 point worse than getting it on the first attempt. So there's no reason to get down on yourself or freak out after missing a problem on the first attempt. So he starts out putting in some double bonds, notes the directions that ask to click structure, aromatize, and takes a minute to read the directions. So the second half of this problem asks the student to map the structure on its most electrophilic positions. So he actually elects not to use SHMO here, instead using some chemical intuition to identify the most electrophilic positions. But of course, to be 100% certain, he could have gone to SHMO and run a calculation to determine the shapes of these molecular orbitals, which we did not, in fact, provide in this problem. He eventually decides to map the two nitrogens as the most electrophilic positions, and as a starting point, this is really not a bad place to start. So starting with those nitrogens, noting that they're unique atoms, he might think this is a good place to get started. So then he backs everything out after getting the problem incorrect and sort of starts again. So at this point now, he draws a different pattern of double bonds, still keeping those two nitrogens the same. The key point in this problem, as we'll see, is to make those nitrogens N2s rather than N3s. There should be double bonds between the nitrogens and one of the adjacent carbons that are lacking in the structure currently. He also forgot to hit that aromatize button, so be careful to read directions that you come across in problems, especially problems with very long directions. Sometimes there will be information there that's a little bit extraneous, but most of the time there are some very important things in there that you'll need to follow in order to either make ACE happy or get something very particular about the response correct. So he checks his time, and with only a minute left, he's kind of feeling the pressure here, right? So he goes right to mapping the nitrogens again, thinking that changing up that double bond pattern is the key to getting this problem correct. And he's incorrect again, and now with only a minute left, he's really pressed. He finally notices that aromatize button still incorrect. And now he finally recognizes that he's got too many pi electrons in this structure. So as it stands, he's got 24 and he needs 22. So he submits, first of all, adding one double bond and then adding a second, but then this structure is sort of nonsensical. So he submits the two double bond structure, finally aromatizes one last time, and ends up getting the problem correct with only 2 seconds remaining. So very tight, very cool under pressure, just methodically, systematically going through and adding those double bonds. This was a really nice example of a student who sort of maintained his composure, but at the same time sort of lit a fire under his butt when he knew that he was in a time crunch. So very nice example, and thanks for watching.